Many see progress and environmental protection as competing priorities, where one must always be chosen over the other. At ELOS, we see things differently. We see a partnership, a balance between improving the quality of our lives and preserving the places we call home. Our services make it possible for projects to move forward while also ensuring that they comply with all laws and regulations, that sensitive wetlands are not damaged or destroyed, that endangered species and habitats are protected, and that invaluable cultural resources are preserved for future generations. This is where we live, where we play, where we raise our families. We strive for a brighter future, but remain committed to the lands we love. ELOS, where natural environments and human interests intersect.
Hello, everyone. Thank you all for joining us. As Bud said, we appreciate you taking the time to come and visit, hang out with us a little bit during your lunch break. Today, we'll be talking about resilient design in construction and what that looks like in today's world with all of the technological advances that we have going on. So, some brief introductions I feel are in order, just in case anyone in the call isn't familiar with ELOS. We'll also talk just very briefly after this about construction management in general, just some basic concepts, and then we'll get into some of the very interesting, fun things that we've been seeing around the industry. So about ELOS, we were founded in 2006, and we have become a multifaceted professional consulting firm over our 18 years in existence. When ELOS was originally founded, we primarily did environmental services such as wetland delineations, getting permits from the Army Corps, cultural resources, things of that nature. But due to our proximity to the coast and being in a coastal area of Louisiana, we've been involved in a lot of disaster recovery efforts over time as well, from all the way from Katrina till now. And so organically, we've grown our service lines based off of the needs that our clients had. And one of those service lines that we've added is construction management and inspection. With that, I'll turn it to Troy and let him introduce himself, and then I'll tell you a little more about myself.
Hi, this is Troy Knockham. So they got a few things on here, but I want to just let you know that I'm an experienced construction manager, inspector, and safety director throughout the 30 plus years in the petrochemical, municipal, and other industries. I pretty much managed as assistant operations manager, looked over safety for multiple construction companies, and did regulatory compliance and incident investigations. So I do have a variety of range of what I do have to offer to ELOS.
And my background is in environmental sciences. I'm originally from Hammond, where ELOS's main office is. I went to Southeastern and started here doing wetland delineations and things of that nature. And over time, got plugged in on a lot of disaster recovery and construction, repair and management projects. And I currently manage our construction inspection department, which includes Troy and a few other people that are site inspectors. So with that, Troy will talk a little bit about construction management, just as a whole, just to make sure that everyone who's in the room kind of has an idea of what types of pieces and parts go into this type of service.
Right, thank you, Dre. So some of the things, managing construction projects, such as road improvements, bridge replacements, rehabilitation, levee projects, drainage improvements, commercial buildings, homes, and every type of infrastructure project. We support the project's achievement, maintenance, and documentation of regulatory guideline compliance, as well as identify, allocate, and track construction activities. The process pretty much set up and coordinate, dealing with arranging and lead of pre-construction meetings, review contractor construction schedule and submittals, and determine a start date for these projects. Prepare a notice to proceed, a letter for signature. tracking of project progress and compliance, daily inspections to ensure compliance with project plans and specifications. We track the progress and compare it to construction completion schedules. Arrange and schedule progress meetings, host meetings with constituents and other stakeholders to address progress and or concerns. The project budget management, we verify work accomplishment and bill quantities, track pay item quantities with dollar amounts as well as overall project budgets, identify possible budget overruns and recommend corrective actions. Preparation of documentations and change order forms for approval. And then project closeouts. Prepare all funded reports, change orders, budgets, quantities, reconciliation, and other special documentation as required for closeout, and then post-construction meetings. These happen on every project that we've been dealing with so far.
So, there can be a good bit that goes into managing construction, of moving parts there. So each one of those aspects is a different phase of construction management. Now, Louisiana and other coastal states have encountered a lot of natural disasters, and a lot of constituents and stakeholders have become more and more aware and concerned about future natural disasters and how do we design to prevent major destruction during these natural disasters. So, creating resilient buildings can go a long way in helping to ensure the safety of occupants within those buildings, but also maintaining continuity of services. So if the building is able to stay intact, if the utilities to the building are able to remain in place, then the services that building usually functions to provide will continue to be there for the community that relies on that. And of course, like I said, this has been more in the forefront in recent years as we've experienced natural disasters that have taken a long time to recover from. So designing for resilience helps to eliminate some of the recovery that's required after those times.
So some of the key aspects of resilient design, one of them is risk assessment and planning. The hazard identification, that's the excessive potential risks in the area, such as earthquakes, hurricanes, floods, or wildfires. This can inform design choices tailored to local conditions. The scenario planning, designed for a range of scenarios, including worst case events, helps create systems and buildings that can adapt under stress. Redundancy, incorporating backup systems for power, water, etc., can help ensure functionality with primary system fails. Material and structural resilience, durable materials, use materials that are resistant to local hazards, corrosion resistant materials in coastal areas. Structural integrity, buildings should be designed to absorb and distribute forces from earthquakes, high winds, and other stresses without collapsing. Flood resilient designs, elevating buildings and incorporating water resistant materials can help protect from rising water levels or flash flooding.
So some other key aspects to resilient design, and mentioned briefly in redundancy and things of that nature, but are energy and resource resilience. So, this can include things such as on-site energy generation from things like solar panels, wind turbines, geothermal systems, and things of that nature, which will ensure that you still have power. Even if the grid were to go down, you'll have backup power. But also water management systems to maintain sewage and clean drinking water to the facilities, should something happen. You've also got energy efficiency, so the building can be designed to be energy efficient. For example, if the power is out, but the building is able to cool and adapt to hotter temperatures through airflow, then that can be a big help to reoccupying the facility. You've also got adaptability and flexibility of these structures. So nowadays, we're seeing more and more modular designs, meaning that each section of a building can be used independent of the other sections of the building. So in the event of a disaster, if one module is destroyed or unusable, then you can move activity into other parts of the building. And you can also expand the building as needed by adding more modules to the building. And then also flexible infrastructure. Now, we're not talking about being able to move and flex with wind, although that can be important. But we're talking about infrastructure that is designed to be able to be future-proof. So as technology upgrades and updates, these buildings can be retrofitted with new technology to keep them up to date.
So some of the key aspects of resilient design, the community and social resilience, design for equity, ensuring that buildings and public infrastructures are accessible and functional for our community members. Particularly during emergency, strengthen social resilience. Public spaces and shelters. Design multi-use spaces that can serve as shelters during the disaster, builds stronger community networks and recovery capabilities. Also, sustainable practices, minimizing environmental impact. Practice such as green buildings certification, LEED and BREEAM. Reduce the carbon footprint and resource consumption, which aligns with the long-term resilience. The ecosystem integration. Resilient design includes features such that work with rather than against the natural environment, such as green roofs, permeable pavements, and native landscapes to manage stormwater and reduce heat islands.
Now, there are obviously some benefits to designing in a resilient nature, and this is why people are beginning to do this more and more and consider having a resilient design. So by having a resilient design, you can not only have more durable materials, more energy efficient designs, but you can realize long-term savings over the life of a building by lowering your maintenance costs, by lowering or sometimes eliminating repair costs, and also by lowering insurance costs, which has become a major factor in recent years. So having a more resilient building makes you more insurable. So structures that are durable can not only save lives during a disaster event by creating a shelter, but also by having a safe place to go after the storm and have shelter. But it's also particularly important to have continuity of services. So having a building that doesn't have a lot of downtime or any downtime after a disaster can allow for the community to rally to that point and still receive services such as food, water, energy, healthcare, whatever that building may be providing to the community.
So some of the smart building materials, the advanced construction materials, which is embedded technology and responsive characteristics that enable buildings to be more efficient, sustainable, and resilient. These materials can respond to environmental changes, optimize energy uses, and enhance occupant comfort and safety. Smart materials are not just a scientific curiosity, but provide real practical benefits that can transform the design, the construction, and upkeep of building environment. Smart materials can amp up the buildings by boosting energy efficiency, cutting maintenance costs, and strengthening structural integrity. The energy efficient, temperature control, smart materials like phase control materials, PCMs, absorb and release heat to maintain stable indoor temperatures. Reducing heating and cooling needs. The lighting efficiency. The electrochromic windows can adjust their transparency to control sunlight entry, reducing the need for artificial lighting and minimizing solar heat gain. The energy harvesting, some materials can convert mechanical stress, vibrations, and sunlight into energy, like some different kind of floors and panels. Sustainability, reduce carbon footprint. The smart materials like self-healing concrete can reduce the need for repairs, prolonging the lifespan of structures and lowering the environmental impact of manufacturing new materials. Waste reduction, the 3D printed construction materials that can precisely control to reduce material waste during these building processes. Some of the cost savings is lower maintenance costs, self-healing materials like concrete that automatically fills cracks, reduce the need for costly repairs and maintenance. Energy savings, enhanced energy efficiency through smart materials sufficiently reduces optimal operational energy costs for heating, cooling, and lighting. Increased durability, self-healing materials like self-repairing polymers or concrete can automatically mend small damages, extending the building's lifespan. Environmental adaptation. The smart materials can adjust to external conditions such as materials that expand or contract with changes in temperature, reducing wear and tear. Improve comfort and safety, adaptive climate control. Smart materials can improve comfort by maintaining consistent indoor temperatures and humidity levels. Safety monitoring, sensors embedded in materials like smart concrete can monitor structural health, detecting stresses or cracks in real time to alert building managers of potential issues that can become dangerous. Automation and integration. Smart system integration, smart materials can interact with building management systems, enabling automated responses to environmental changes. For example, smart glass can tint automatically when exposed to bright sunlight, or HVAC systems can adjust based on room occupancy and temperature changes detected by smart surfaces. Aesthetic flexibility, customization, building facets and interiors can be dynamically adjusted to meet aesthetic and functional requirements in real time. Dynamic facets, smart materials such as electrochromic or thermochromic facets allow buildings to change their appearance based on the temperature of lighting, enabling creative architectural designs.
So those are some of the key aspects that you find from smart building materials and some of the reasons why you may use these smart building materials. So now we're going to talk about a few actual materials that accomplish some of these things that Troy just touched on. So the first type of material that we'll talk about is self-healing concrete. So seems kind of crazy, like how would that happen? But the Romans actually first discovered this, according to MIT and Harvard researchers who were studying structures in Rome. They found that Romans would add limestone into the mix, which when that is exposed to moisture or the elements will actually produce more stone and start helping to fill that crack. So nowadays there are also advanced technologies where bacteria are embedded into the concrete, and those bacteria, when exposed to the elements, will cause a chemical reaction, which will help fill the crack. So what this does is helps improve the durability of concrete by, one, maintaining the structural integrity of the concrete, but also by preventing things like moisture to penetrate the concrete and continue to erode it away. Another type of material, a neat material, is smart glass. So when you think of electrochromatic glass, think of transitions lenses. So most people are probably familiar with those glasses. When the sun hits them, they get darker. So this can be a key feature in buildings that have a lot of glass surfaces. If this is added to the glass, it can help maintain the interior temperature of the building, the comfort of the occupants, and can also help to bring down your energy costs for those rooms.
Aerogel is insulation. The super lightweight material with excellent insulating properties, often referred to as frozen smoke. Although aerogels were first invented in the 1930s, NASA's Glenn Research Center in Cleveland has invented groundbreaking methods for creating new types of aerogels that could change the way that we think about insulation.
So we've also got graphene-based materials. Now, many of you are probably familiar with graphite, which is a type of lead that's used in pencils. When you write on paper, the graphite transfers onto the paper. Graphite is actually composed of many layers of graphene, which is a single atom layer of hexagonal connected carbon atoms. And so this material was discovered to be extremely strong, about 200 times stronger than steel is whenever it's embedded into materials. So you can put coatings of this material onto the surface, or it can be embedded within. It will improve the strength, the durability, and also the conductivity of that material, which it can be crucial in resilient design as well. We'll talk a little bit more about electrically conductive materials and what those can do. But by adding this to a surface, you can use that surface to help generate energy. Good, smart coatings.
All right, let's talk about smart coatings, like paint infused with nanoparticles or sensors that provide real-time data about the building's structural health or environmental conditions. Designed to remain passive until their surfaces are stimulated by external agent that causes the properties to be activated, like light, temperature, etc. Used in numerous industries, including automotive, shipbuilding, or architecture.
Next material is smart bricks. Now, smart bricks can also be used in conjunction with several of these other materials that we were just talking about, such as the graphene or the smart coatings that we were just mentioning. But in essence, because brick is a somewhat porous material, you can embed small sensors into the bricks. And those sensors can be programmed to monitor things such as changes in load, pressure, and stress on the bricks to monitor structural integrity. But they can also monitor environmental conditions potentially within a space, such as air quality, relative humidity, temperature, things of that nature, which can also be important to the overall structural integrity of a building. Some smart bricks are even designed with small microbial fuel cells. So these are types of bacteria that will undergo chemical reactions that actually produce fuel or can produce electrical charge. And so this power can be stored on site for in case of emergency. If power were to go down, it could generate that. So again, that also ties back in with graphene layers, which can also help to enhance that electric conductivity of a material.
There's also translucent wood that has been chemically treated to remove its lignin and then infused with a polymer to create a translucent material. Just like on this diagram that's on the screen, approximately 3 times stronger than transparent plastics like plexiglass, or in about 10 times tougher than glass. This could soon find uses in super strong screens for smartphones, in soft glowing light fixtures, or even as structural fixtures, such as color changing windows.
All right, then the last material we'll talk about are hydroceramics. So as the name implies, these are types of ceramic materials that have a hydrogel embedded within the material. As you can see in the picture, this kind of grayish stuff would be the hydrogel. Now the hydrogel not only helps to absorb and control moisture content, thereby helping to maintain a certain relative humidity within your space, But it can also help to control acoustic or sound vibrations within a space to help dampen in areas that tend to be loud. It can help prevent having too high of an audio level there. Not only that, but hydroceramics are also fire resistant due to having the hydrogel embedded within them. So what this does in a way is makes this material very fire resistant or heat resistant in a similar way that asbestos is. So a lot of oil and gas and industry are starting to turn to hydroceramics to coat places where need to protect from heat rather than using asbestos, which can be dangerous if disturbed.
All right, we'll go ahead and open things up for questions now. If you have a question, please feel free to type it into the chat box. And we will try our best to get it answered for you. I am also adding email addresses for our two presenters to the chat box. Should you think of a question later and want to reach out for more information.
I do want to say to the group, you know, a lot of things that we've talked about today they're cutting edge technologies. They're being implemented selectively at the moment, but that's how a lot of technologies come online. They're tested in specific instances and then extrapolated onto bigger projects. So, you know, we see a lot of very interesting and exciting changes going on in the construction world, from how things are designed, how things are managed, and the materials that are being used. So we're excited about moving forward.
Okay, does anyone have any questions? Please feel free to enter it into the chat box. All right, I'm not seeing any questions. That obviously means our presenters did a fabulous job. I will remind you that the recording of this presentation will be made available on our YouTube channel, probably within the next couple of days. You'll receive an email notification when it is available, in case you want to rewatch it or share with any colleagues or friends you think might be interested. Again, in the chat box are the email addresses for our two presenters. Should you think of a question later, please feel free to shoot them an email and they'll be more than happy to get back with you with an answer. And if there are no questions, which I'm not seeing in the chat box, we will wish you a good rest of your day. Thank you for joining us. Please follow us on social media, as this is a monthly series that we do of educational webinars. So check in with us on LinkedIn, Facebook, and see what our next topic is going to be. And if there are any topics you'd like us to cover, please feel free to contact us through our website. And we'll be more than happy to take a look at putting something together for the topic you're interested in. So with that, we'll wish you a good rest of your day. Thank you again for joining us, and take care.
Bye, everyone.